What's up guys, welcome back to a brand new academic learning video, and in this video we are going to be going over systems of equations. Alright, so let's get started. So system means more than one. Or how about this? Because we're doing math greater than 1. But first, to understand systems of equations, you just have to understand how general equations work. So let's do a quick review. Now, an equation, the main part of an equation is this equal sign. And this equal sign basically says that the left side and the right side have the same value to each other. So let's give an example, 3x plus 4 equals 7. Now this is saying that the left side and the right side have the same value with each other. And now, if we do the same things to both sides, then the left side and the right side should still have the same value. And this is what I like to call the equality being preserved, because they still have the same value to each other. And now, eventually, if you get clever with it, you can solve for variables, because we know that the left side and the right side are equal to each other, so we know that x equals 1. So that's what just general equations are. And if we have one variable, like this, we just have one solution. So that's it, one x value solution. What if we have something like, well, two variables, like 3x plus 4y equals 7? Well, in this case, you kind of have infinite solutions. You can have, let's see, x equals 1, you could have x equals 1, y equals 1, x equals 2, y equals y equals 1 over 4. And you might notice something here. For the first equation, our solutions just came in the form of x equals some number. But in this, we have sets of x and y values, because we don't just have one variable anymore, we have two. And to see why we have infinite solutions, let's do a graph. Okay, so this is just a quick sketch. Okay, so 3x plus 4y equals 7, what does that mean, like if we graph something? Well, let's start off with just a graph like this. Now, how you can think of this graph is you plug in x values and get the corresponding y values to get some ordered pairs. That is a good way to think about it if you just have a simple input and output. But in this scenario, it's more difficult than that. You have just these two variables, and you say if you do a bunch of operations to them, they equal 7. So there's no really simple input and output. So how we can graph this is, well, how we can think of this graph is the set of all x and y values that satisfy this equation. And that's true for any equation. If we graph it, it's just the set of all values that satisfy this equation. Even this input and output graph up here, that's still, you can think of it as the set of all x and y values that satisfy the equation. Because if you have an input and output value, then that input and output value will satisfy that equation. Okay, so you may be wondering, well, why is that the definition? And the truth is, it doesn't really need to be. It's just a connection between algebraic equations and geometric graphs that just makes intuitive sense, so that's why they picked it. Okay, so now that we know that a graph is basically all the values that satisfy a certain equation, we also know that if we just pick any point on the graph, then that x and y value point will also satisfy, hold on, let me label my axes, will also satisfy that equation, because again, a graph is the solution for, the graph is the collection of points that satisfies, an equation is the collection of points that satisfies all of the, the graph of an equation is the set of points that satisfy the equation. Sorry, that was a bit confusing. I'm not sure I worded that right. But hopefully you get the point now. So, you may be wondering, well, what does this have to do with anything? Well, if we have a simple graph, like a line, 3x plus 4y equals 7, you can tell that this is a line because it's linear, which means that the highest exponent is 1. If you're confused about that, then I will link a video in the description below about slope and linear functions, but that's not really the focus of this video. Okay, so if we just have a line like this, we know that there's going to be infinite points. So there's going to be infinite values, x and y values that satisfy this equation. But what if we had two equations? What if instead of 3x plus 4y equals 7, we also had something like 4x plus 5y equals 3? Now, this line, I'm probably not drawing this correctly, but it doesn't really matter. So if we had a line like this, now you see that there's one point that they both meet up. And that point right there will satisfy both of the equations because the point is on both of the lines. So that's what we mean by solving a system of equations. We're just finding a point where both of the equations intersect with one another, because that will give us the values for both. That will give us the x and y value that satisfies both of the equations. And now technically, not every not every system of equations does have a solution. Hold on, how do I get rid of this? Okay, there. Not every system of equation does have a solution. For example, if we do have something like this, and the lines are parallel, well, by definition, parallel lines never intersect, so we won't get a point. That's basically the only case of lines not having a solution. And this video, we're only going to be focusing on lines, but just to remember, you could also do like parabolas or cubics. It doesn't really matter. But usually you'll see them as lines or linear functions. And also, we don't need to have x and y. It's just that the graph is in x and y, but you can make the graph in like t and s or z and x. It doesn't really matter. So now that we've gone over what is the solution to a system of equations, let's go over how to actually solve them. Well, one way is to just graph them and see where they intersect, but that's kind of tedious. Not everyone has a graph on them. So another way we could do it, algebraically, is, let's draw our systems of equations. Or let's write it down. So one way we could do this is maybe like, we want just one variable. If we can solve just one variable, either x or y, then we can plug that in to one of the equations and solve for the other variable. So for example, if we know that x equals 1, then we can plug that into this equation. So we know that 3 times 1 plus 4 times y equals 7, or that, I'm just going to skip a few steps here, 4y equals 4, or that y equals 1. And this is just kind of intuitive, because we know that x equals 1, so we know that we can plug it in and solve for y. And if we solve for x right, then we should get the same value of y no matter what equation we plug it in, because we're solving for the same variable. Okay, but that's easier said than done. How do we get just one variable by itself? Well, we need to get an equation with just that one variable, so we then can solve for that variable. So we need to get an equation like this. Now we can solve for that variable. So, and to get an equation with just one variable, you have to eliminate another variable. So that's how we do it. We eliminate one variable. And there are two methods we can use for eliminating a variable. One is called substitution, which is probably the most reliable method. And the other is called, well, elimination, which is useful in some circumstances. Let's go over substitution first. So substitution is just getting one variable in terms of another. So first step is to pick an equation. So let's just pick the bottom equation. And now we want to pick a variable. It doesn't really matter which variable we pick. So let's do y. So now here we can just solve for y how we would normally. But instead of solving it as a number, we're solving it as an expression in terms of x. If that doesn't make sense, stick with me because it might make sense once we do it. Okay, so that's the first step. The first step for substitution is to get one variable in terms of another. And how you can do this is just rearranging the equation to get this. And now that we have one variable in terms of another, we can plug that variable back in, and now we just have an equation with just one variable. We eliminated the y value. But if you try it with the second equation, actually, let me label our equations. If we try to plug it back in with our second equations, you'll see something. It won't give us any useful information. Let's actually see that. So instead of y, we plug in 9 minus 4x divided by 5 equals 9. That and that cancel. So 4x plus 9 minus 4x equals 9. Or that 9 equals 9. And this doesn't give us any useful information. We can't solve for x knowing this. And the reason for that is you're just using one equation. And we can't get any information with just one equation. Because if you think back to our graph example, it's going to be infinitely many points. So we can't get any useful x and y values points. We have to use the other equation to get some useful information. So no matter what equation you pick first to solve, you have to plug it back to the other equation. And that will give you your variable. And another way to think of this, why you can't just plug it back into the first equation, is that because you got that information from that equation, and if you plug it back in, you're just going to get the same information. That might have been a bit confusing, so hopefully one of those explanations made sense, but if not, just leave a comment. Okay, so let's say we plug it now into the other equation now. So we get 3x plus 4y, which is 9 minus 4x divided by 5. And the algebra can get a little complicated here, but stick with me. It gets 3x plus, and now we distribute the 4. 3x plus 36 minus 16x on 5 equals 7. Let's see, this is a bit complicated. Well, we could multiply the top and bottom by 5 here to get 15 over 5x plus 36 minus 16x over 5 equals 7, or that. And you probably get the point here. We're basically just solving for x. And let's just say x will probably be some fraction. Let's just say x equals 1. So now we can plug that back into either of our equations. Let's just do the bottom one. So we get that 4 times 1 plus 5y equals 9, or that 5y equals 5, or that y equals 1. So that is basically how we do it. And if that didn't make a lot of sense, if you see a couple more examples, it probably will make some more sense. So if you want to see some more examples, I have a link in the description with some more examples of how to do substitution. And I will also have a link for how to do elimination. But just as a recap, first step is to get one equation, pick one, it could be either one, and then solve for one variable in terms of another. Now that once you have that one variable in terms of another, you can plug that back in, not into the equation that you found that from, but to the other equation, and then you can solve. And then you have an equation with just one variable. So you can solve for that variable and then plug that back in. So systems of equations are quite tedious, as you can tell probably, but once you see it a couple times, it shouldn't be too daunting. Okay, so let's go over the second example, which is called elimination. And to better showcase elimination, I'm going to give you a pretty common elimination example like this. Now, one way we could do it is just to, well, if you see right here, if we just add x minus y plus x plus y, we just eliminate one of the variables, and boom, now we just have an equation with one variable. Well, not yet, because we have to deal with the other side. So we have 7, and then, now we have to add x plus y to the, or actually, just to give this a better example, so you have x minus y equals 7, first of all. Now you're adding x plus y to both sides. So plus x plus y, so you get 2x. So now you've eliminated one variable already, so you can see how this can be a pretty nice shortcut. But what about on the right-hand side? What do we do here? Well, we don't want to add x plus y to the right-hand side again, because that will give us more variables, and we're trying to eliminate our variables. So one way is we have to add the same value to both sides, but we don't necessarily have to add the same thing, because instead of adding x plus y, we know that has the same value as 4. So instead, we could just add 4. So now 2x equals 11, so x equals 11 over 2. So now that we have one of the variables, we can plug that back into either of the equations. That will give us our other variable. So you can see how this might be pretty useful. If we can just add it to both things, then we can just eliminate a variable pretty quickly. So that can be a pretty cool shortcut. But what if we have something like this? But what if now we can't just add the equations or subtract the equations to eliminate one of the variables? But there is another solution we can do here. So let's just take the first equation and multiply it both sides by 4. So then we get, well, 12x plus 16y equals 28. On the second equation, let's multiply both sides by 3. And stick with me here, because this may seem a bit unintuitive at first. So we get 12x plus 15y equals, well, 3 times 9 is 27. Okay, so now what we basically did is multiply both the equations by a number to get them to the same coefficient here. And now we can subtract the equations. So we have 12x plus 6y. So now we can subtract 12x plus 15y. And whatever we do to the left, we must do to the right. So we subtract. Instead of subtracting 12x plus 15y, we know that's the same thing as 27. So on the right-hand side, we get 1. And on the left-hand side, now that and that will cancel. And 6y minus 15y, that's minus 9y. Or that y equals negative 1 over 9. Okay, now that might have been a bit tedious as well. So this is where elimination becomes kind of not that useful, because now we have to do one extra step. We have to get them into the same coefficient, and then we subtract it to eliminate the coefficient. So that can be a bit tedious. Okay, so now let's just review, because there was a lot in this video. Systems of equations are 2 or more equations that have multiple variables for solutions. And now, to solve these, you could graph it, or you could do 2 methods, substitution or elimination. Now, both of these methods work by eliminating one of the variables and then solving for one of the variables. And once you know one variable, you can just plug that in and find the other variable. So that's the main thing. Just solve for one variable, and then you can solve for the other one. And substitution does this by Sorry, let me just draw this out. Substitution does this by getting one variable in terms of another, and then plugging that back in to the top. And elimination does this by getting the variables to have a same coefficient. Then they can add or subtract that to eliminate that coefficient from that variable. Okay, now, if you have any questions, please leave them in the comments below. Or if you're not confused about how it works, but you just want more examples, then you can look at the link below where I have a bunch of different examples of how you can do this. And then hopefully by then you should be more comfortable with it. But now, hopefully, you should understand at least some of the theory behind it. But if not, just leave them in the comments below. And yeah, I'll see you in the next video.